Cool if I use the presenter view? That'll show up on your end, okay?
Well, it'll show the presenter view on my end. So we're mirroring the laptop, not the projector.
Oh, crap. Okay.
Here's the thing. If you need that view to do your presentation, you can.
Sure.
I would rather have you do a good presentation than not. Does that make sense? Yes, that's perfect. Let's make that a little bit bigger.
I still see some of my notes, but I don't read my notes verbatim, so.
Oh, that's okay. So here's the. These are the things no one else thinks about but me, so I appreciate it that you're coming in here with that. That's great.
Sometimes I wonder, like, I think you can see my cursor. I'll just pretend like we can.
All right, folks at home, I'm asking you if you could please let me know if you can hear my voice, and you could let me know in the chat that you hear my voice. Yes. Okay, very good. Thank you so much. I appreciate it. Okay. Oh, I wanted to ask you one more thing.
Yeah.
Do you like the lights all the way on, or would you like them a little bit off like this?
What do you think? A little darker, or is that okay?
This is good?
Okay. I don't like it totally dark.
No, I don't either. No. This is nice. It's not too.
Yeah. Exactly.
Okay. Well, let's get this thing started. Huh? Why not? And I'm just going to make sure you got your packs on before we.
Do you want me to turn them on now?
If you don't mind, just make sure that they're on. Awesome. Okay. All right. Good evening, everybody. Hello. My name is Matt Bender. I'm the Adult Program Coordinator here at the Schaumburg Township District Library. Welcome to tonight's hybrid programs. Welcome to you here in the room. Welcome to you there at home. Thank you for joining us tonight for an amazing program talking about going back to the moon. Who is excited? Huh? Come on. Going to the moon. All right, anyway. Okay. Let me remind you of the things I remind you of every single time that we're together. For those of you at home, we have closed captioning enabled. You can enable or disable it in your Zoom tools. It's either on the top of your screen or the bottom of your screen, and you can change it from there. For our friends here with me in the room, first, our restrooms are to your right. Women's restroom is right outside the door here, and then the men's restroom, if you go toward the end of the book stacks, you'll find it on the left-hand side. Between those two doors is our water fountain and also a water bottle filling station. I imagine most of you brought cell phones with us. So if you could take a look at those one more time before we get started, and please silence them, put them on vibrate, whatever you have to do. All right, before we get started, let me talk about two things that are coming up that I'm very excited about. First, as you know, St. Paddy's Day is just around the corner, and on Sunday, March 19th, we're continuing our Sunday Sounds program series with the Irish band Trillium. So come on in, Sunday, March 19th at 1:30. Here's some great free Irish music. You don't even have to order anything. You can just sit down and have a good time. All right, 1:30 here in this room on Sunday. Then on Wednesday, March 22nd, on Zoom from the comfort of your own home, you can learn how to do some Irish cooking. Kristen Slick, who we had in the past, she's fantastic. She takes us through some of her recipes that she does in the comfort of her own kitchen, and hopes that in the comfort of your own kitchen, you'll learn how to do these things. So if you want to bake along with her, you want to cook along with her, you can. If you just want to watch her, that's fine too. Either way, that is on Wednesday, March 22nd, 7 p.m. on Zoom. These programs and all programs we offer here at the library are mailed to you in our program flyer. When you get that at the beginning of the cycle, hang on to it, because it's got 3 months worth of information. And if you have any questions about signing up, head on over to the wonderful people at our info desk. They'd be happy to answer any questions you have, sign you up for anything that you like between now and May of this year. So check out what we got going on. Okay. That is more than enough for me. I am now going to pass it over to one of our favorite presenters of all time, the Director of Public Observing at the Adler Planetarium, Michelle Nichols.
Thank you. It is so fabulous to see you all in person, and those of you who are online, I know you're there. So I don't know how many of you are there, but I know you're there. Hi, everybody. How you doing? Hi. So by the way, I will just echo what Matt just said. If you think your phone is off, but you didn't check it, double check, because whoever invariably thinks they turned it off, they're like, oh no, it'll call me in the middle of the program. Yes, they will. So anyway, so this is an interesting program. This is an interesting time to do this program. We are poised to hopefully return people to the moon for the first time in more than 50 years. It's still going to be a few more years before we see actual human boot prints back on the surface of the moon. But I'm going to tell you a bit about the Artemis program. So what is it going to do? Where are they going to go? What are we going to study? Because wait, haven't we been to the moon, right? We've been there. What's the point of going back? So anyway, we're going to talk about various topics related to all that. So let's get started. Well, the moon is Earth's closest neighbor. It is easy to see in the daytime and at night. Oh, by the way, I totally forgot. Those of you who are online, I'm apologizing in advance for whatever the closed captioning system turns my talk into. So apologies in advance for any technical translations of words and things, because sometimes scientific words may not translate very well for closed captioning. So anyway, good humor is appreciated for those who are online. Anyway, so our moon is definitely easy to see in the daytime and at nighttime. And for a long time, we wondered what the moon was like. And finally, in the latter half of the 20th century, we finally got to go there. We first went with unmanned spacecraft. So the first spacecraft we sent to the moon, we weren't even able to send spacecraft into orbit around the moon. Basically, we just wanted to get stuff there to learn what the surface of the moon was like. We knew even in the late 1950s that we were going to send people to the moon. It was still up in the air as to exactly when that would happen. It wasn't until President Kennedy's speech in 1961 that sent us to the moon at the end of the decade. But so we knew we were going to go. We just didn't know an awful lot about the surface of the moon. So the first efforts that we had were to send the spacecraft called Lunar Ranger. And Lunar Ranger was essentially put cameras on a spacecraft and lob them at the moon. And they would take pictures all the way down to the surface. You could get closer pictures than any telescope on Earth could possibly get if you were sending a spacecraft there, and it would take pictures all the way till it crashed. And so what you're seeing in this set of pictures is a little bit north of what eventually became the Apollo 11 moon landing site. And that last picture, which is on the upper right, that picture was in the process of being sent back to Earth when the spacecraft crashed. So, but still, what we learned was, wow, the moon was cratered and cratered and cratered and cratered. So we needed to learn a bit more about the surface. So a little bit later, we're able to send spacecraft in the mid-1960s into orbit, and we call those lunar orbiter. And this is a picture taken by Lunar Orbiter 3 of Kepler crater, named for Johannes Kepler. It's a 20-mile wide crater. And what I love about this picture is because of the angle of the spacecraft and the angle of the sunlight, you really can tell what stuff splashed out of the crater when the rock from space slammed into the surface of the moon. And so when that thing from space ran into the moon, this material splashed out of the crater and onto the surface. And you can see all that stuff all around. It's that very rocky looking stuff that's around the crater. By the way, if you're wondering what size object made a 20-mile wide crater, you can roughly guesstimate that it was about 1/10 the size of the crater. So it was about a 2-mile wide-ish impactor that made that crater. So that's a pretty big rock. But there was still a lot of question among scientists about what exactly the surface of the moon was like. So we didn't want to send our first steps onto the surface of the moon be people at a spacecraft with people in it landing on the moon, because we didn't actually know for certain if the moon's surface could hold a spacecraft. There was one camp of scientists who were like, no, it's fine. You can send people to the moon, no problem. But there was another camp who were saying, well, but the moon's been pummeled by stuff for the last however many billion years. What if the layer of dust is super thick? What if you try to land a spacecraft on that dust and your spacecraft just sinks right into it? Then you might not get your spacecraft back off the surface of the moon. Your humans might be stuck there. So you want to sacrifice a robot before you sacrifice the people to be able to go. So we had the Lunar Surveyor spacecraft. There were several of them successfully land on the surface of the moon. In this case, about 2 years prior to the Apollo 11 mission. The first thing that this spacecraft pretty much took a picture of was its feet. If you could see its feet on the dust, you had a pretty good chance of that spacecraft being safely landed on the surface. And as you look in this picture, there you can see the spacecraft's feet. It turns out the lunar dust on the surface is only about 2 inches thick. No problem, right? And we've got a few other pictures. Surveyor 1 is the one that's labeled in the lower right-hand picture. Surveyor 3 is the top right, and I can't remember which one is on the far left, but still you can see the shadow of these spacecraft. One of these Surveyor spacecraft, the Apollo 12 spacecraft, landed not too far away, and the astronauts bunny hopped over to the Surveyor spacecraft, grabbed pieces off of it, and brought them back. It was a perfect environment to be able to learn what happens to something when you leave it out on the surface of the moon for a couple years, when it gets blasted by radiation from the sun and hit by stuff from space and things like that. So we were able to do a little science experiment by going and retrieving pieces from one of the surveyors, thanks to the Apollo 12 landing. But I mentioned it was Apollo that finally landed people on the moon. The first several Apollo missions were test flights. So Apollo 7 was a test flight in orbit around the Earth. Apollo 8 was a test flight in orbit around the moon. Apollo 8 wasn't actually originally supposed to go into orbit around the moon. They were supposed to do a test of the spacecraft and the lunar lander, but in Earth orbit. But the lunar lander section of it wasn't done yet. So NASA got together and they went, what could we do? Well, let's take a page from the Soviets' playbook and just go for the gusto. Let's go for the really impactful thing. We're just going to go into orbit around the moon. Why not? And so they did, and it worked. And so that was in 1968. Apollo 9 was the Apollo spacecraft and the lunar lander in orbit around the Earth, a test there. Apollo 10 was all of that in orbit around the moon. And if Apollo 10 went as planned, then Apollo 11 would be the one to land on the moon. There was no guarantee that Apollo 11 was going to be the one that actually landed. It just depended on how well Apollo 10 went. If Apollo 10 went okay, but NASA felt that they needed more testing, Apollo 11 would have been a test flight, but they didn't need it. It went well. And we landed our astronauts on the moon. 12 people in all walked on the surface of the moon. This is Commander John Young, and it was on the Apollo 16 mission. And what he has arrayed around him are some of the scientific instruments that were along for the ride, that were placed out on the surface of the moon. So over to his right, your left, that is a drill, a rock drill. So it's a portion of a drill. The rest of the drill is to his left, your right. This dark thing over in the back, that is an electricity generator. And there are a few other instruments as well. But basically, there were various scientific instruments that were installed on the surface of the moon, including this one over here. I believe it's the one to the back left, his back right. We left mirrors on the surface of the moon. So the goal would be shoot a laser from the Earth, reflect off of those mirrors, and you could time how long it took for the laser to get from the Earth to the moon and back. If you're ever talking with someone and they're a moon hoax aficionado, well, the only way you can get a laser beam returning to the Earth that was fired at the moon is if there's something reflective on the moon to get the mirrored image back to you. So that is, these are experiments that still go on today. I actually saw one of the laser systems not operating, but there is one of these moon lasers that is at the Apache Point Observatory in New Mexico. There's, I think, at least one other one at another observatory. But we can do very precise ranging of how far the moon is from the Earth and figure out how quickly the moon is receding away from us as it does. So we also have other instruments that would tell us about the surface of the moon and the subsurface, the rock below the surface, so the interior. There's other ways to do it too. This is the passive seismic experiment. That's the one in the foreground right there. And you can see that electricity generator right here. It used the decay of plutonium to be able to generate electricity. So that's this thing right here. But the passive seismic experiment was an experiment that would just wait for stuff to hit the moon. And it would register the moonquakes that would result from that. So when something from space smashes into the moon, be it a rock or a piece of a rocket or something like that, then you could actually measure the moonquake waves under the surface. How they transmit through the surface tells you about the subsurface without even having to dig down and to be able to see it yourself. I love this one. This is the active seismic experiment. How do you have an active seismic experiment? You lob mortar shells at the moon from this thing. It basically launched little mortars that would explode on the surface of the moon, and you could actually get the moonquakes from that. So you could either wait for something to hit the moon, and you could generate your own moonquakes yourself. Did you have any idea there were basically grenades on the moon? That was basically this. So the various experiments taught us a lot. One of the main things we learned from the Apollo missions was where the moon came from. It seems like such a basic question. You would have thought, oh, we figured that out long ago. No, we only figured it out within the last 50 years. Where did the moon come from? The leading theory based on actual scientific data from the moon rocks themselves was that the moon formed when something the size of Mars hit the Earth, not too long after the Earth formed. Material splashed out and formed the moon. The reason we know that is because when we take a look at the moon rocks and Earth rocks are remarkably similar. If these two objects formed separately, they should not be as similar. They would be more dissimilar than we see them, but they are remarkably similar. There are a lot of moon rocks are a lot like the rocks in the crust of the Earth. And so This was an incredible scientific advancement to be able to learn this from the rocks that the astronauts brought back. Indeed, it was one of the very first things, or it was the very first thing that Neil Armstrong did. As soon as he stepped off the lunar lander, what did he do after he said his most famous words? He grabbed a rock and stuck it in his pocket, essentially. He stuck it in a little bag, and I think then stuck it in his pocket. But basically, if anything went wrong after that point, at least we had a rock. And he and Buzz could hightail it back to Earth. Well, luckily that wasn't needed. And we brought back in total about 800 pounds of rocks over the 6 missions that landed people on the moon. The Apollo missions, if you take a look at where they landed mainly near the equator of the moon. It is just easier to land near an object's equator. Large parts of the moon were not explored. Yes, we have sent spacecraft into orbit around the moon, and surveying pictures and other things have been done, but we've only directly explored 6 places on the moon. Try to characterize the Earth by landing on 6 places. Could you do it? I don't think so. At least you wouldn't be able to do it very completely. Wouldn't be able to do it well. There are, I mentioned, large parts of the surface that we've never explored, especially the poles. So since the Apollo missions, especially in about the last 20 years, we've learned that there is water ice locked up in some of the craters at the North Pole and at the South Pole at the moon. And where you see it highlighted in blue on these images is where we've detected this water ice. Now, if you go, oh, we've detected it indirectly, well, yes, but we've also detected it directly. There was a spacecraft mission called LCROSS, and in 2000, the Lunar Crater Observation and Sensing Satellite. In 2009, this was a 2-part spacecraft, and the first part slammed into a shadowed crater at the moon's south pole. Another spacecraft was trailing behind about 4 minutes later, flew through the plume of stuff that the impactor had dug up, sampled it directly, and just like Lunar Ranger, right before that thing hit, it transmitted all the information back as to what that plume was made of. And that plume was partly made of water ice. There is ice that is in these craters because where the ice collects, and maybe it's from comets that have hit the moon and the ice collects in the craters, and there's other ways to make this water ice. The mechanism isn't the important part. Basically, these craters are shadowed because the sun doesn't get above the rim of the craters. So the crater rims are down below the surface, and the sun at the poles doesn't get high enough in the sky to heat up the floors of the craters. So if the ice gets in there, it's not going anywhere. So at least the first few inches or so of layers of these craters are made of water ice, with some dust, of course, mixed in. But there's quite a bit of water there, meaning this could be a very valuable resource for future missions. So we wouldn't have to cart all the water there, either for the astronauts to drink, or water can be useful in another way. If you take the oxygen that water is made of and you split the molecule, you can use the oxygen to breathe. You can use the hydrogen for rocket fuel. So there are a variety of ways and options for using this as a resource. So this exists at the South Pole. We would like to know more about that area. And also another positive thing about the poles is there are a few locations at the poles where it's basically sunlit almost all the time, if not all the time. So at the heights, the tippy top heights of some of the rims of these craters, not at the poles, or sorry, not at the floors of the craters, but the tippy top heights, there's some of those areas that are basically in sunshine all the time. Whereas every other part of the moon is going to be dark for a period of time. Every time the moon goes around the Earth, except for a few of these places, which means you could have a permanent way to generate electricity if you use solar power at that South Pole area especially. So where are we going to send our humans to explore the surface of the moon in the future? We're going to go to the South Pole. Now the South Pole is harder to reach, but the abundance of potential resources there and learning about an area of the moon we haven't seen with our eyes directly would be really valuable. So Artemis is the name of the moon program. It is the follow-on to Apollo. Artemis is the twin sister of Apollo. So if you're wondering what the mythological connection is, that's what it is. In this case, for Artemis, one of the goals is to land the first woman and the next man on the moon, the first person of color on the moon. We want to explore more of the lunar surface than just the easy to reach places. And we want to learn what we use to eventually go to Mars. Forgive me, this is going to sound like a humble brag, and I really don't mean it to. I have to tell you about this little story, and I will sound like I'm bragging based on the circumstances of the story, but it'll make sense in a second. In, what was it, 2009, if I'm not mistaken, 40th anniversary of Apollo 11. I was having lunch with Buzz Aldrin. Sorry. I realize it sounds like I'm bragging, but I was invited to lunch with Buzz Aldrin. It was at work. It's for work, really. And he was talking all about going to the moon. And yes, we went to the moon. The man went to the moon. The man decked a guy for saying that he didn't go to the moon. He absolutely walked on the moon. And he was saying, yes, we've been to the moon, but we need to think of the moon as an off-ramp to a farther distant location. The moon is an off-ramp on the trip to Mars or an asteroid or both. So he was adamant that we think farther. And I think finally people really started to listen to that message. It took a while because people were like, moon, been there, done that. Why are we doing that? It was kind of a fault of the original moon landing program. The goal was get there before the Russians, before the end of the 1960s. Great. Once we did that, there was nothing else to achieve. There was no long-term goal. There wasn't something else to keep reaching for. So once we did it, we're like, all right, been there, done that, move on. This is a much longer-term goal, unfortunately without a clear timeline, but that's nothing new with space exploration. It's hard, it's expensive, it's going to take a long time. But eventually we're going to learn what we use to send people to Mars. It'll happen. Will it happen in my lifetime? I honestly can't tell you if it will. But that humanity will land on Mars at some point in the future. All right, who's going to get us there? So we've got NASA. There are various NASA programs, and NASA is working with external partners to be able to accomplish these programs. And these are government contractors and commercial for-profit companies, such as Boeing, Axiom Space, Blue Origin, SpaceX, and various others. And so all of those together make up many NASA programs, one of which is Artemis. So you'll often see Artemis shorthanded in links on the NASA website as Moon to Mars. Not just Artemis, it's because Artemis is going to the moon, but this really is Moon to Mars, and Artemis is part of that. The rocket that will get us to the moon is called the Space Launch System, and the spacecraft is called Orion. This rocket is 177 feet long, and the parts of it look eerily familiar if you remember the space shuttle, right? So you have the two solid rocket boosters, the white boosters at the sides. They are a little bit longer than the shuttle rocket boosters were. Why? Because you need to get this spacecraft going faster than the space shuttle did to be able to eventually escape Earth's gravity. So those boosters were as big as they needed to be to get the shuttle into orbit. Well, to help get the shuttle into orbit. This one, the whole thing needs to be bigger than what set the space shuttle up. One tidbit that I find fascinating is each solid rocket booster is as tall as the Leaning Tower of Pisa. And when I read that, I went, I had no idea the Leaning Tower of Pisa was that tall. It seems so short when you've got all these tourists who stand many feet away from it and like do this in their pictures, right? So, and frame it in the background. Anyway, the Space Launch System, or SLS, while it's a little bit shorter, or it's definitely shorter, than the Saturn V rocket was, which was 363 feet tall, the Space Launch System is more powerful. This rocket is currently the most powerful rocket to ever have launched from the surface of the Earth. It has more thrust than the Saturn V, which is pretty cool. Now, there are many parts, but the part that I want to point out is, see this little guy right here, that crew module spacecraft, that is the only part that comes back. They don't go retrieve anything else. So the only part to come back to Earth is the part that carries the people. So we've got the main solid rocket boosters, those are the white ones. We've got the orange tank, that's the fuel tank for the rockets here at the bottom. So the solid rocket boosters have their own rocket engines. And the fuel tank for the main rocket itself, that's the orange part. The reason it's orange is covered in similar material as the external tank for the space shuttle. It was an insulation material. Then you've got an adapter basically connecting this part to these parts. You've got the stage which then gets it going toward getting higher up away from the Earth. You've got more adapters to connect stuff. And then you finally have the part that gets it going on its way to the moon. And it makes its way around, does whatever it is they're going to do, and then they come back. So the Orion spacecraft is attached to a service module. So the spacecraft itself is the cone-shaped part at the top. And the cylindrical piece underneath it is the service module. It's provided by the European Space Agency. Basically, European Space Agency provides the service module. European Space Agency astronauts get a ride to the moon. Easy as that. Usually in space, no money is ever exchanged. You exchange stuff. It's the ultimate barter system. You give me a thing for my rocket, I will give you a ride on my rocket to the moon. So the service module provides electricity and water and oxygen and breathable air, all that, for the astronauts to live. The service module is based on this thing. This is the European Automated Transfer Vehicle. The European Space Agency used this vehicle to bring supplies to the International Space Station from 2008 to 2014. And so basically, what you're going to hear me say quite a bit is, we've used some of this technology before. We know it works. Why develop all brand new stuff when you don't have to? So NASA and its partners have been working toward these efforts for many years. And so they're basically looking around going, all right, we've already used successfully this system to get stuff from A to B. Let's use what we learned to attach to Orion and get that to the moon. Orion is partly based on the Apollo spacecraft. It is a little bit bigger. Here's the interior. And it has space for 4 to 6 astronauts. The next mission that will take astronauts up, they'll have 4 people. But it's about 50% larger by volume than Apollo. It is still not a whole lot of room, especially when you consider that these missions will last about 3 weeks minimum. So imagine staying in something that probably has less habitable volume than a small bedroom for 4 people for at least 3 weeks. That's a lot. That's a long time. All right. I'm not going to go over all the diagrams. What I'm going to describe to you, so these are the only diagrams I've been able to find that concisely explain what the different Artemis missions are. Again, don't pay attention to actually reading everything on here, because I'm not going to read everything off. So Artemis 1 was last year. So that was November, December. What happened was they launched the Space Launch System rocket with the Orion crew capsule on top, with the European service module hooked onto it. They launched all that to the moon, no people. It basically went out, went around the moon for a while, and came back. They wanted to test all that out before you stick people on it. You want to make sure that everything works before you put people on the rocket. So this was the launch of that mission. And what I find fascinating is, so down below, is the launch platform. Well, it's a mobile launch platform. Basically, NASA has a system, the crawler transporter, which goes and picks up the mobile launcher with the rocket on it, takes it out to the launch pad, they launch the rocket, they get the crawler out there, they bring the launch pad back, and then they refurbish it for the next mission. Well, there was a little bit more damage than they were expecting from the launch. So you can't really see it on here, but there were things like about 60 panels on here that were destroyed. Elevators were destroyed. The mission caused a little more damage than they were expecting. So they are currently fixing the mobile launcher. Again, the mobile launcher is this part here at the bottom, and the launch tower itself, the crawler transporter, is this thing here at the bottom. If you've ever gotten a chance to take a tour of Kennedy Space Center, you might have seen the crawler transporter off in the distance. They used this to get the Apollo Saturn V rockets out to the moon. They used this to get the space shuttle to the launch pad. They used the space shuttle out to the launch pad too. I got a chance to see one of these things up close. It is enormous, absolutely enormous. Anyway, so they're in the process of fixing the damage that the launch caused. Analysis of the mission itself. So this is a real picture from just outside the spacecraft. It met or exceeded all of the testing that they were doing for the flight. They even added in some tests that they wanted to do during the flight. They're like, well, this is going real well. Why don't we add some more stuff that we can try for, that we weren't planning on? Why not? The European module created more power than they were expecting, and the whole system used less power than they were expecting. Everything went well. The arrival back on Earth was only about 2.5 miles from the targeted landing point, which is fantastic, especially since they moved the landing point about 300 miles farther away because of poor weather where they wanted to land. So anyway, that went really well. They're also examining the heat shield of Orion, the bottom part of the cone-shaped, gumdrop-shaped spacecraft. It actually came back with more material than they were expecting. They were expecting more of it to burn off. I guess if you're gonna have a spacecraft come back, you would want more of your heat shield remaining than less than what you were expecting. But they're still trying to understand exactly why. They were modeling it and expecting more of it to have burned off than it did. So still trying to figure out why. Anyway, I'd say at least it went in that direction, not burned up your spacecraft on reentry, right? Artemis 2. So Artemis 2 is scheduled to happen potentially in late 2024, possibly early 2025. This will be the first rocket to send people to the moon in orbit. This will not land on the surface of the moon. What they're going to do is basically an Apollo 8 style mission. Put 4 astronauts in, get them to the moon, go around the moon, and come back. So that's the goal of that mission. Test everything before we land on the surface, and be able to do as much as they possibly can with people. So Monday, April 3rd, they will announce the crew for the Artemis 2 mission. It will be 3 NASA astronauts and 1 Canadian Space Agency astronaut. So stay tuned for a big announcement coming up in about a week and a half. Artemis 3. All right, again, this looks complicated, but I'll boil it down. Send astronauts to the moon, go into orbit around the moon, transfer over to a rocket that will land on the moon, do some stuff on the moon for a few days, come back, transfer back the Orion spacecraft, and come back to Earth. That's the gist of it. That's Orion. That's Artemis 3. And that says landing on the moon in 2024. Don't expect it before 2026. So this drawing is already out of date. One main reason for the delay is Blue Origin. So Jeff Bezos's company was not happy with the selection of SpaceX as the company that would land the astronauts on the surface of the moon itself. They filed a lawsuit, and that delayed everything. NASA basically said, okay, SpaceX, you need to stop working on all this till we get this lawsuit straightened out. And that stopped all work for 7 months. And in space terms, 7 months is an eternity. And this was during the pandemic. So pandemic delays added on to that 7 months. So don't expect Artemis 3 before 2026. Artemis 4. This will be the one that will involve most, if not all, of the main pieces of this whole system. One piece of this system I have not yet described is called Lunar Gateway. So, all right, Artemis 4, launch to the moon, go into orbit around the moon, hook up with a space station that's in orbit around the moon, do some stuff on the space station, transfer over to a lunar lander, land on the moon, do some on the moon, come back to Gateway, transfer back over to Orion, and go back to Earth. Basically what all that says. So Artemis 4 probably won't be the one to land people on the moon, though. So what I just described will probably be Artemis 5. There may be a gap between Artemis 3, landing people on the moon, and Artemis 5, landing people on the moon. You're going, wait a minute, but you're landing people on the moon. Why is there a gap? Well, because the system that will land us on the moon in Artemis 3 is not the final system. It's just a get us on the moon system while we can, do the final version later. So it's not the final configuration that will get us to the moon. So Artemis 3 is just do it however you can. Artemis 4 is go back to the moon and do some stuff with the Lunar Gateway space station, and if you can land on the moon, fine, but if not, no big deal. Artemis 5, put it all together. Does that make sense? Kinda? All right, clear as mud, that's good. Artemis 5 is no earlier than 2027, which usually means sometime past 2027. Okay, I was just describing something that you probably have not heard of, and that is Lunar Gateway. Lunar Gateway is essentially going to be the follow-on to the International Space Station. The International Space Station is scheduled to be deorbited or decommissioned in approximately the year 2030. Everybody goes, oh my God, that's awful. Well, it will have been flying, pieces of it will have been orbiting since 1998. It's time. You don't want to keep people on a 30-plus-year-old orbiting spacecraft. They already are having problems with little leaks here and there from stuff hitting it and causing little holes and things. It happens. There's not much you can do about it. But they're like, you know, it's time to move on. And so NASA's going to move on with Lunar Gateway. And it's going to look something like this. It's going to be a dedicated space station that will orbit the moon, composed of several parts. So the power and propulsion element, you can pretty much guess what that's for, generating the electricity, making sure it gets there, right? The habitation and logistics outpost, habitation, the parts where the people live, and then the logistics module, the part that has all the stuff, the stuff that, you know, humans need to stay alive, all that kind of stuff. So lots of different pieces. The habitation and logistics module is called HALO, and this is where the astronauts will spend their time. Up to 30 days they could spend in orbit around the moon. They've got space to live. They've got docking ports where visiting spacecraft can hang out. Life support systems, all sorts of fun stuff. So basically, this is the guts of Lunar Gateway. This is the place where the people will be. This habitation module is based on Cygnus. This is Northrop Grumman's Cygnus spacecraft. And Cygnus has been bringing cargo to and from the space station for years. And so basically they're like, well, gut out one of those Cygnus spacecraft and put in some stuff to keep people alive. Hey, no problem. And so these are cargo resupply missions for the space station, but HALO is the next generation of that particular spacecraft. The logistics module, you're gonna need supplies of cargo every now and then, you know, send the water, the food, and all this sort of fun stuff, scientific experiments. And so the logistics module is the portion of the Gateway that's gonna do that. Notice these are all drawings. None of this stuff exists currently, so they're working on it. Anyway, there will be additional modules added later from the Canadian Space Agency the Japanese Space Agency, and the European Space Agency. So Gateway will get bigger. It's going to start off smaller, and it will get bigger over time. So we're going to go to the moon. What are we going to do? Well, this is a picture of one of the Apollo extravehicular activities, EVAs, moonwalks. Again, one of the main goals was collect lots of rocks and rock samples. The astronauts were trained by geologists to identify different interesting looking rock samples. So it wasn't just, oh, just randomly pick stuff up. They were actively going around looking and going, oh, that looks interesting. I know what kind of rock that is, or that looks like an interesting rock, more than that over there, so we'll go collect this bit over here. They were trained to try to identify the good samples to bring back. They're already working on designing tools. These are some of the tools that they're working on. So I'm going to see if I can identify stuff here. All right, so we've got, actually, the folks online can see my cursor and you can't. So how about the bag on the very top? That is a sample bag. The thing just below it to the right is a scoop. It kind of looks like a scoop, looks like a space age scoop. You got the thing slightly to the left and below that scoop, that's your geology hammer. And you got various rakes and tools and sample collection things. I like the one, let's see, 1, 2, 3, 4, fourth item from the top, that long handled thing with the claws on the end. It kind of looks like one of those toys that you might have had a kid or a grandkid in the past, but with a little thing with the claw on the end and you can go grab stuff. Well, it's basically a NASA version of that. And lots of different ways to collect rocks. They have been testing some of this stuff already. These are actual tests at the Rock Yard at Johnson Space Center. This is daytime testing because some of these rock collections will happen when it's sunlit out. So you want to see what all this is like. And you can see they all have masks on. This was during the pandemic. Yes, I realize we're still in a pandemic, but this was during the height of the pandemic when this testing was going on. They also were testing at night because you want to see how easy it is to use this stuff when you can't quite see as much. Here's another test at night. The wheeled object there on the right is a sample tool carrier, or sample carrier for tools or rock samples. So they have to build all this stuff. The tool carrier doesn't actually exist yet. Everything you see in this drawing, including the lander at the background, I'll bet you including the American flag in the background, does not exist. They need to develop the lights and the scoops and the tool carriers and the lunar buggy that will eventually move people around, and the lander itself, and all this stuff still needs to be worked on. So amazing. Including general maintenance tools. What if something breaks and you need to fix it? You need to even develop all that stuff. You can't just go down to the local Home Depot and get this stuff off the shelf. You need to make sure that it can survive in the lunar environment. And you're thinking, well, why? My hammer is pretty sturdy. I've had it for 40 years. Well, if we're looking at this particular drawing, and if it's in the darkness, what temperatures are these astronauts experiencing outside their spacesuits? About 200 degrees below zero. And then in the sunshine, it'll be about 200 degrees above zero. So these are temperature variations that our normal everyday Home Depot tools are not going to be able to withstand. So that's why they need to make all this stuff to make sure it can handle all this. So what's coming up tomorrow is NASA and Axiom Space are going to reveal the lunar spacesuit. So can't tell you what it's going to look like. I have no idea. This is the picture that NASA put on the announcement page saying it's coming March 15th. Well, that's tomorrow. So they're going to reveal the Artemis 3 lunar landing spacesuit. So stay tuned for that. We'll see what it looks like. I bet it'll be looking very space agey. So we'll see. Anyway, between now and then, what is also going to happen are uncrewed missions. What that means is missions without people on them. And just like the Lunar Ranger, Lunar Orbiter, and Lunar Surveyor missions helped us learn more about the surface of the moon, these missions are going to bring scientific experiments to the surface of the moon, especially in areas we have not yet sent people. hopefully areas that we want to send people to in the future. So one of the newly announced payloads is called Lunar Vertex. And this particular mission is going to go to a place called Rainier Gamma. It is this area on the surface of the moon. There we go. So it's going to this spot right here. Do you see the swirly looking lighter colored soil there on the surface? The surface of the moon has some of these swirls that where you might see swirly bits and streaks and things. The moon has these swirls and we don't know what causes them. There's no wind on the moon. There's no air on the moon. There should be nothing that moves the dust around like this. They think it has something to do with magnetic fields, local magnetic fields in these areas, but they're not quite sure. So they're going to send this mission to take magnetic field measurements as this little rover drives across the surface, without people, drives across the surface of the moon, taking the measurements all along where those swirls are, because they think these magnetic fields are very localized. So they want to see, is that really true? So they want to drive across these swirls to start to figure out what causes them. Why do we care about this? Well, localized magnetic fields are an environment that the spacesuits will have to protect against, and even the spacesuits themselves. If you think about the Apollo spacesuits, I don't know if you ever paid, actually, I'm going to go back. I wasn't planning on doing this, but hang on. You take a look. Do you notice everything from like the thigh down on this astronaut, how incredibly dusty it is? The lunar dust is so fine, it's so powdery, it staticked itself to basically every surface that was that was on the outside of these spacesuits. When these astronauts went back into the lunar lander, they were covered in dust, and it wasn't like they could just like brush it and it would fall off. It stuck itself to everything. Then the problem was, once they took off the spacesuits in the same environment, they were now breathing in this dust. This dust is essentially like breathing in glass. It is incredibly hazardous. And so we need to learn more about this lunar environment, not only how the dust interacts with the spacesuits, how the dust interacts with the local environment, because these are going to be places where we've got people going. So we need to know about this before we send people there. And so these are areas where we really don't know a lot about them. So we want to check that out. Another place that a couple more payloads are going to go is on the far side of the moon, a place called Schrödinger Crater. And they're going to send a seismograph to measure moonquakes. How often does the moon's far side get hit by stuff? All of our seismographs before were on the near side. We didn't have anything on the far side. So we're going to put something on the far side. And then another one is to learn about the moon's interior temperature. So this will hopefully help shed light on the far side of the moon, which is an area that, again, we've never sent people. So this is going to be risky. This is going to be expensive. It already is expensive. There's already Congress people going, what are we spending all this on? It could be potentially scientifically amazingly rewarding. It could very well be the next step with sending people to Mars eventually. Well, we have a long way to go before we get there. A lot has to go right for all of this to work. So stay tuned. So I would love to know if you have questions. Please.
Does the moon have a molten core?
The question for those online is, does the moon have a molten core? We don't think so. If it is, it's a small molten layer. It's not enough that would break through and cause lunar volcanoes like we had in the far distant lunar past. There used to be volcanoes on the surface of the moon, not anymore. Based on what we know so far, it looks as though the moon at least appears to be fairly stable inside, but there still seems to be some movement on the surface. So not quite exactly sure what the whole interior structure of the moon is. We know more about the interior structure of Mars than we know of the moon. So kind of a question mark, exactly what the various layers are and what their state is. So I find that fascinating every time I think about it. The Mars Insight mission taught us about what exactly the interior of Mars is like, and we have not yet had a similar type of experiment on the surface of the moon. Hopefully that'll be changing soon. So good question. Yes?
Does other countries like Russia have stuff on the moon also, and is it like ours or is it different?
So the question was, do other countries like Russia have anything on the surface of the moon? Is it like ours? Is it not? Russia, no. Russia never successfully sent people to the moon. After we landed astronauts on the moon, the Soviet Union did successfully send some robotic spacecraft to the surface, including one that was able to scoop up a tiny bit of lunar material and robotically bring it back. Russia tried to do that while our Apollo 11 astronauts were on the moon. They tried to do all that with a robot. It didn't work. But they were able to do it a year or two later. So there is that. They also did successfully drive a lunar rover on a robotic lunar rover on the surface. All that stuff is still there, but none of that is operating. China landed some spacecraft on the surface of the moon. They landed a rover on the near side. They landed a rover on the far side. So China successfully landed a rover that is, as far as I know, still operating on the far side of the moon. They need an extra spacecraft farther out to be able to allow that far side rover to communicate with Earth. Otherwise, there's no way to do it because Earth is on the other side of the moon. So that's basically it. There have been a handful of other spacecraft that have tried to land on the surface, robots. Israel tried to send a private spacecraft to the moon. No people. It crashed. It almost made it. It was so close. They had a little trouble on the way down. I think that's it. India has sent stuff into orbit around the moon, and I believe they've got a spacecraft in the works to land something on the moon. I don't remember exactly when. The more I'm talking, the more I'm remembering. So if you're wondering why this is sounding piecemeal, it's because I'm thinking and talking at the same time. I do that a lot. Anyway, I think that's it. Yes?
When the current space station is used, you can't allow it to lose its orbit and fall to the Earth, then wouldn't they have a mechanism to fire it further out into space?
So basically, yeah, the question is, how do you get something the size of the space station back down? What do you do with it? What do you decommission? How do you decommission it, right? So the answer is, what they would do is do a controlled reentry. You wouldn't send it farther out. You could, but you would send it into a controlled reentry into the Earth's atmosphere. By controlled, it means you keep a spacecraft attached to it, use the rocket thrusters of that particular spacecraft to then send it to a planned burn up and splashdown in the central South Pacific Ocean, which is where a lot of our other spacecraft that have done controlled reentries have landed, because you don't want something the size of a football field just randomly coming down over the Earth. Yeah. So we've sent quite a few spacecraft into a watery grave in that area, and then no one worries about going to pick them up. No one goes to the South Pacific to worry about any of that stuff. What's the power source for Artemis? Yes, it is solar. Yes, all solar. There may be. I don't know if there is a radioisotope thermoelectric generator or plutonium power source. I don't think so. I believe it's all solar, if I'm not mistaken. Any questions from our friends online? Yes. Yes, SpaceX Starship progress. So progressing. So SpaceX is producing the Starship rocket, Starship spacecraft. The Starship is what they're going to use potentially for Artemis 3. And what that might entail is, and this is the part I really didn't get into because I get confused every time I try to think about it. So send Orion up. Sorry, before you even send Orion up, since Artemis 3 is the one that will land on the moon, but with a non-standard lunar lander. You're going to send essentially an empty Starship rocket up into space. You're going to send other rockets up to it to fill it with fuel. You're then going to send that thing to lunar orbit. Orion will meet up with it, transfer over. They will use that to land on the surface of the moon, do some stuff, stay around for 6.5 days, get back up into space, connect back up with Orion, and then Orion comes back. If you're thinking to yourself, that sounds complicated, you're right. And SpaceX is in charge of this. They've been highly successful with their stuff before. We'll see how it all goes. We'll see how it all goes. I will reserve my judgment for when they do more robust testing of Starship, like sending it to, orbit at all. I don't believe it has launched into Earth orbit yet. So eventually they'll get there. We'll see. Makes me nervous. It really does. It really makes me nervous that we're going to use essentially a one-time system to get people to and from the moon. So we'll see. Yes.
How many active astronauts do we have?
Oh, how many active astronauts do we have? Bless you. Gosh, that's a great question. I don't know the number offhand. It's probably somewhere in the dozens. I can tell you how many people have gone into space. It's like 600. It's probably somewhere in the dozens. They have a new astronaut class every couple, 2-3 years or so, and each astronaut class is somewhere in the 8 to 12-ish people range. And there's some astronauts who are holdovers from the space station era, astronauts who come onto the system in the last 10 years or so. Some are very recent. So yeah, I'm going to guess it's in the dozens. If someone in our online audience wants to look that up, that would be great. So I wouldn't mind the research help. Yes.
As a follow-up to a question, they undergo the training that the original Mercury astronauts.
Oh, do those current astronauts undergo the training of the original Mercury astronauts? Kind of. Except we now know what spaceflight is actually like. When the Mercury astronauts were doing, we had no idea what they would need to be able to endure. The Mercury astronauts essentially had to do a heck of a lot more in terms of endure a heck of a lot more in terms of G load and all of that, and Mercury, Gemini, Apollo, all those. Things are a lot more tame these days, especially at the space shuttle. Maximum number of G's you would pull was about 3. I believe for Orion, the maximum number of G's they'll pull is like 6. So worse, but not terrible. So would they still do the centrifuge and all that stuff? Absolutely, absolutely, yes. So they would do flight training, they would do training on all the switches and dials and gears and everything having to do with all the systems on the spacecraft. They'd probably have some medical training in case something went wrong medically. They would have all the science training. It's an insane amount of training that they're going to have. So I would say in some aspects, it's tamer than Mercury. In other ways, it's a lot more, practice a lot more.
You probably get asked this all the time. If you could, would you go into space? Is there any realistic possibility that you could?
Would I go to space if I could? And is there any realistic? If you had asked me that question 20 years ago, I would have said absolutely. But not surprisingly, the older I get, I'm like, no, I'm good. I can stay on the ground. That's okay. I kind of don't even like airplane flying, so might not be the greatest candidate for astronaut school. Is there any realistic opportunity for me specifically? No. For people like me, sure. Yeah. And it's mostly from the private companies. The private companies, you can be a space tourist at just about any age. William Shatner just went up at age whatever he is, 90, I think. Wally Funk just went up and she was 80 something or other. And if I got the opportunity to go up for maybe 10 minutes, sure. Okay. Maybe. I don't know. It is still a tourist rocket, but anyway, we might be able to talk about that. But for the actual space program, no. They're gonna want folks who are younger because they're gonna want them to stick around for a while because we don't know when they're gonna go up into space. They could be in training for 10 years before they finally make it onto a crew.
Someone replied to your request for help.
Yes?
As of December of 22, there are 41 active astronauts consisting of 16 women, 25 men. 39% of those are female and 61 male.
Nice. That's pretty cool. All right. Thank you. Thank you to the person online who looked that up. That's a higher percentage of female astronauts than I was expecting, actually. That's pretty good. So what was it, 30, 39, 41?
41 total.
41 total. So a few dozen, yeah. Probably a lower number than at the height of the space shuttle program because we were sending them up 5, 6, 7 at a time. So the crews are smaller and they're not gonna go up as often. So they're not gonna need as many astronauts these days, more than likely, so yes.
Are we sending probes to any other celestial areas that are more similar to Earth's characteristics?
Are we sending any spacecraft to other places that are more similar to Earth characteristics? And the answer, yeah, or probes. The answer is yes, every time we send something to Mars. So Mars at least has a temperature that is kind of a little more similar to Earth than the moon is. The only drawback is it's so far away. That's why the moon is so appealing, even though it's less hospitable, more hostile, it's a lot closer and it's a lot easier to reach. So trying to think if there are any Mars spacecraft going anytime soon. The European Space Agency still has to send their rover called Rosalind Franklin. That's going to go in a few years. And I thought there was one more. I can't remember who. China has an operating spacecraft on Mars right now. India has an orbiting spacecraft. We have at least a couple orbiters. We've got the 2 rovers. But I don't think we've got anything on the docket for Mars anytime soon. I think we've kind of Marsed out for a while. Sending a couple $2 billion rovers, I think. Oh, that's good. Mars for a while. So I don't think we've got anything anytime soon.
How far is Mars from?
How far is Mars? So if you go straight line distance between Earth's orbit and Mars's orbit, it's only about 50 million miles farther out. But the problem is you're not going to go in a straight line from Earth to Mars. You're going to have to follow a curved path. So while it's a 50 million mile difference between Earth's orbit and then Mars farther out, that curved path to get you from Earth to Mars is going to be about a 200 million mile journey, one way. Mm-hmm. Yep. Stuff in space is far. Yes. Yes. Mm-hmm. Mm-hmm. Excellent question. So how much junk and stuff is out there, just in general? Earth orbit, a lot. More going up practically every few days. SpaceX keeps sending up its Starlink satellites. Amazon, Bezos keeps sending up, there's some satellites that they want to send up too, for internet access, so global internet access. There are literally thousands of these satellites that are going to be going up. Every time one of those dies, you now have a piece of space junk. There aren't humongously robust plans to deorbit everything. There is for some, but there should be for everything, and there isn't, not all the time. And so space junk is an ever increasing problem. Less right now for the surface of the moon than it is to even just getting into low Earth orbit, because you've got all these spacecraft. And there will be, if all the spacecraft go up that people have planned, we're talking tens of thousands of satellites. And every time one of these goes up, you may have a rocket piece that falls off, or an astronaut loses something over the side of the space station or whatever. Now, the government already tracks thousands of pieces of space junk in low Earth orbit. Then you've got all the satellites in low Earth orbit, middle orbits, high orbits, the geostationary satellites. Every time one of those goes defunct, you now have a piece of space junk. And the farther away it is from Earth, you don't have as much of an opportunity to burn it up in Earth's atmosphere, because it's just literally too far away. On the surface of the moon, it's less about junk and more about, what is it? Is it junk? Is it a museum piece? Is it a tourist destination? So this is something that we have to talk about at some point, because the original Space Act basically said space belongs to no one. Well, of course it doesn't, because no one could reach it, or no one could actually bring anything back, or anything like that. So it made sense. Like, no, you're not going to go mine the moon. Well, we're getting closer to being able to mine the moon or mine an asteroid. Can you do that? How do you do that? Who owns this stuff? Is it finders keepers? Does it belong to a government, a private entity? Don't know. Does it become like Antarctica? Don't know. They're even starting to try to figure out what time zone is the moon. Did you see that? And you think about it, what clock do they follow? Someone's going to have to figure this out when we send people, right? So when you're talking about a place like Mars, now you're talking about an environment that has the possibility that maybe under the surface, or maybe somewhere on the surface that we just don't know about. What if life exists? Do we want to contaminate Mars with Earth stuff? What are the ethics of all of that? What are the ethics of going to the moon? What are the ethics of going to Mars? Or the ethics of sending spacecraft to a place like Europa, or any place else? How about the ethics of crashing our spacecraft on purpose onto a portion of the moon? What are the discussions around all of that? So there's a lot to be discussed, and I just gave a lot of hand waving to your question, because a lot of this still hasn't been totally figured out. But there is a lot of stuff up there yet to be determined what we consider all that stuff, depending on where it is. But in low Earth orbit, there's a heck of a lot of space junk up there. And if we get a heck of a lot more, it's going to start to impede our ability to send people up into space at all, because it will be too dangerous. Did you see the movie Gravity? That part at the beginning where a collision causes a collision, and it eventually tears apart the space station? Sorry, I should have said spoiler alert. Too late. That movie was out 10 years ago or whatever it was. It's becoming more of a reality, more of a possibility of a reality. Ooh, that was just a downer. We need a science question. Go ahead, yes.
What is the projection for a man landing on Mars?
Projection for people landing on Mars. For my entire lifetime, probably for your entire lifetime, it's been 30 years, right? In the 1960s, Wernher von Braun thought we'd be walking on Mars in the 80s or 90s. When I was a kid, 30 years in the future, right? In 1999, we did a temporary exhibit project at Adler called the Mars Millennium Project, imagining a habitat on Mars for 30 years in the future. Well, that would have been the year 2029. Last time I checked, in the year 2029, are we going to have a habitat on Mars? No. It seemed possible then. It forever seems 30 years in the future. A colleague of mine is a lot more optimistic than I am about eventually getting people to Mars. He thinks it will happen in our lifetime, but no earlier than, I'd say, the 2050s, which is about 30 years in the future, actually, because we're not even going to be able to send anything to go retrieve the rock samples that the Perseverance rover just placed on the surface of Mars in special little tubes to go get picked up by a spacecraft until the early 2030s. We won't even have the ability to send a robot to go pick up little bits of stuff that another robot left for another 10 years or so. Sending people is immeasurably harder and more expensive because you gotta, like, keep them alive. You gotta, people have to breathe and eat and, so I'm being facetious, but I'm kind of not.
Are they actively working on it, or is it really just on the next one?
Are they actively working on it? Is there an actual program like Artemis to get people to Mars? No, there isn't. No. They can say Artemis will eventually get us to Mars. Sure, you can always hand wave and say that. But there is no concerted, NASA is not currently training an astronaut who will be the one to walk on Mars. That's not happening right now. So, yes.
Okay, I heard on the radio that they're going to be sending DNA from 4 presidents.
They're going to be sending DNA from 4 presidents into space?
Yes.
Really?
Kennedy, I heard it today.
Kennedy, Washington. And it was not the
I
other
forgot
two.
the other two, but they're sending DNA up
Huh.
like next week.
Of 4 ex-presidents, former presidents, up into space.
Yes.
Huh. Why? Who's gonna do it? Some probably private spacecraft.
I don't know.
Online who was doing the research. Can you look that up? Apparently it was news today. Okay, well, we'll check that out. Whoever is doing my research for me, thank you, thumbs up. So, yes, ma'am.
I want to go back a couple of 100 million years.
Couple of 100 million years in the past, okay.
That moon
Yep.
came from material from the Earth.
Mm-hmm.
That's a lot of material.
Mm-hmm.
How did the Earth then not just spin out of orbit? Or
Yeah, so when the Mars-sized thing impacted the Earth, how did that not completely send Earth out of its orbit or anything? It would have, possibly, there's one set of simulations that said it may have completely vaporized the Earth. That seems a little less likely. It probably was a glancing blow. So a Mars-sized thing glanced Earth and stuff splashed out and formed the moon. So it sounds like a catastrophic event, and it was. It would have completely decimated the surface of the Earth. But the surface of the Earth may still have been partly molten then anyway. Mars is about half the size of Earth. It's a very large thing, but it still would take an awfully large thing to send Earth out of orbit. It's basically like like you're playing pool. In order to send a ball from one side of the table to the other, the ball that you're hitting it with is the same size. If it's a smaller ball, then that ball might go off, or it might send the bigger ball into a path, but not completely out of off the table or anything. So it's the physics of it did an awful lot of damage, but it wouldn't have sent it completely out. It's interesting to think about, though. So yes.
What happened to that Mars-sized?
I've wondered about that myself. What happened to the Mars thing? Because it depends on if it completely vaporized the Earth, then it would have completely vaporized the Mars thing too. And some of that Mars stuff, whatever that Mars-sized, I keep saying Mars, it wasn't Mars, but that Mars-sized object, which I think someone gave the name Thea, it would have been incorporated into the Earth. Part of it anyway. It was a glancing blow, it might have kept going. So it might have gone out somewhere, so yes.
Yeah, and then it also contributed to the asteroid belt.
May have contributed to the asteroid belt?
But because the president's DNA, it's a space burial company, Celestic, and it's going to be sending the, some remains, it says symbolic remains, George Washington, Dwight Eisenhower, John Kennedy, and Ronald Reagan, and also Gene Roddenberry and James Doohan.
There's less and less of Gene Roddenberry and James Doohan. They've already been sent up into space, right?
And how do they have DNA from Washington?
How do they have DNA from Washington? That's true. Symbolic DNA. Does that mean, is there a descendant that they could get DNA from? So for those online, if you didn't already look it up, it was the symbolic presidential DNA was Washington, Eisenhower, Kennedy, and Reagan, and Gene Roddenberry and James Doohan. So Scotty and the creator of Star Trek, who've already partly been sent to space before. So anyway, what?
More than once. Roddenberry.
At least once, maybe. Anyway, yes, and back, yes.
In the future, how much more will private enterprise take over in space exploration?
Great.
I mean, are we going to see space conquistadores?
Great question. How much in the future are the private companies going to be playing a part in all of the space exploration? More and more. Because what NASA has decided is it is essentially going to turn low Earth orbit over to the private companies. We're getting out of the space station realm and essentially moving our efforts to the moon. And that would mean you're a private company, you want to send up a spacecraft? Hey, NASA knows how to build a spacecraft. Here's the information that NASA has learned over the last many decades about sending up spacecraft. You can use that information and send up your own spacecraft. There are already companies working on their own private space stations, inflatable space stations, tourist destinations, all of this. Whether or not it will actually become feasible to pay for all that, yet to be determined. But more and more NASA is relying on these private companies to be able of system. However, please remember, it is still NASA money paying for it. It's up to the companies then to take what they've learned and try to figure out how to monetize that whole system. And whether or not they can make money back that they've paid in, we'll see. We'll see. So it could either be a boon for tourism, you know, the billionaire who just doesn't know what to pay for wants to go to space. So that's already happened a few times. To be determined as to what exactly the roles the private companies will play. They are currently playing a role because they are handling some of the work that NASA can't do, or NASA isn't able to do itself with the workforce it has. So they have workforces, NASA gives them money from its budget, pays for that stuff by contract. So we'll see where that all goes in the future. So, in the back, yes.
Question on this organization of NASA. We hear about Artemis.
Yes.
And then there's another story we hear about for sending spacecraft or sending an object up to impact an asteroid.
Mm-hmm. Mm-hmm. Mm-hmm.
At the entity level, how many different functions or areas is NASA organized in?
Ooh.
Spacecraft.
Yeah.
Let's go after an asteroid, you know?
Yeah, great question.
How do you get
Yep.
grasp on what's going on?
The group of writ large. What are all those areas that NASA does? NASA does, the first A in NASA is aeronautical. NASA does airplane research. That is one area of NASA. The uncrewed, unmanned, unpeopled spacecraft, that is the Science Mission Directorate at NASA. Then there is the manned or crewed spaceflight section of NASA. That's mainly out of Johnson Space Center. And there are other smaller areas, but those are some of your main sections of NASA. Most of which are not composed of people who directly work for NASA. A lot of the various day-to-day functions of NASA are done by contractors. So even like NASA's internet access or NASA's website or whatever, those are done by commercial companies who are paid by NASA's budget in order to actively do all those functions. The number of people who work directly for NASA is actually quite a bit lower than you think. I think it's in the tens of thousands, whereas all the people working based on NASA's budget is a lot bigger than that, but they're all from those private firms. But Aeronautical Research, Science Mission Directorate, the manned space flight, I'm probably forgetting some individual areas, but those are some of the main regions of NASA. Anything else? Yes.
When Thea hit the Earth,
Yes.
do we know where it hit?
When Thea hit the Earth, do we know where it hit? No. No, there was a hypothesis many years ago that it formed, that's the basin formed by the Pacific Ocean. Probably heard that at some point. It wasn't. There's no way that was the case. But no, there's no way to know where it actually hit.
Where to identify, because there were no consonants.
Yeah, there's no, the surface may not even have been solid at that point, so, yeah. All right.
How do I get my wife to volunteer to be the first woman on the moon?
How do you get your wife to volunteer to be the first one on the moon? I think by the way she's looking at you right now, there is much dishwashing in your future. No, I don't know. I mean, if you want to volunteer, give NASA a call. All right. Any other questions? Anything from our folks online? Are we all good? All good? Anything else? Thank you, everybody. This is a great discussion. So can't wait to see you again. I can't remember. Do we have a program do we have one for the eclipses? I can't remember. Yes, we do. Yes, we do. Hang on. I have it in my calendar. Hang on. Let me look it up. Because, libraries, they started getting on my calendar like 2 years ago. Tuesday, March 19th, 2024. I'll be here talking about the solar eclipse coming up in April 2024. So you'll see me in a year. Thank you, everybody. Appreciate it.